Good evening all. You're welcome to tutorial with from Encanting the Schoolboy. Today we are going to take a look at chemistry assignments. We review this our chemistry assignment. I hope you did the assignment. Okay, actually come out. Come out. Don't cry. Come out. So number one says the presence of impurities in a solid will make the melting point to A, decrease, B, increase, C, remain unchanged, D, be zero. A is what? Decrease. How?
Because I see that like impurities, they may.
I gotta sit down. You say what?
If I see that impurities may make like melting point
Okay.
will decrease.
Okay.
Yes.
Is that reason?
Yes.
Do you agree with her? Okay. It's true. The answer is A, decrease. The presence of melting, the presence of impurities in a solid will make the melting point to what? Decrease. It's also a criteria for. I studied that is one of the criteria for purity. If you get a solid and you want to check whether this solid is actually what it is, you check the melting point of the literature value of the melting point of the supposed substance that you expected that it should be there. Then check the melting point of the what? Of the substance you have at hand. If the melting point is lower than the melting point in the literature, it's a sign that substance you have at hand is not pure. Something extra is there. You need to find out what is inside. Is it clear? Is it clear? All right. Number 2 says the boiling point of a liquid is defined as the temperature A, at which its vapor pressure equals the atmospheric pressure. B, at which bubbles begin to form. C, at which the vapor pressure equals 1 atmosphere. D, at which the rate of condensation of vapor equals the rate of vaporization of the liquid. Chiwell, what's the answer? Huh? What's the answer? No idea. A. The normal boiling point of a liquid is defined as the temperature at which its vapor pressure equals the atmospheric pressure. Why do you say A? Huh? Why do you say A?
For example, now you're boiling water. As
Chinaya, what is the answer?
that is A.
Why do you say A?
Because because the boiling point, like the temperature, vapor pressure is equal to the atmospheric pressure.
You say what?
Because the vapor pressure of a like normal liquid, the boiling point here, the vapor pressure is equal to the atmospheric pressure. Is A.
Izu, what is the answer? Number 2. What is the answer to number 2? Huh? A. Why do you say A?
Because when the liquid is boiled, when it starts evaporating, is when the water will begin to turn to gas and mix with the atmospheric pressure.
This question this is just a definition of boiling point. Are we together? You just define boiling point, but you don't know. They just use the option to confuse it. Just the question just talks about what definition of what boiling point. That is standard definition of boiling point. Boiling point is the temperature at which the water happens. Vapor pressure equals the what? Atmospheric what? Pressure. Temperature at which the vapor pressure of a liquid equals the what? Atmospheric what? Pressure. You can Google it on your own. Check the definition of boiling point. You appreciate it. Are we together? So check up the definition of what? Boiling point. That is the definition of a boiling point. The answer is A. Number 3. In an experiment, which of the following observations would suggest that a solid sample is a mixture? In an experiment, which of the following observations would suggest that a solid sample is a mixture? D. A. Solid can be grounded to a fine powder. B. The density of the solid is 2.25 grams per dm cube. C. Solid begins to melt at 573 Kelvin, but is not completely melted until 648 Kelvin. D. Solid melts at 300 Kelvin. Izu, what's the answer? A says what? Solid can be grounded to a fine powder. Why did you say A? Huh? Why did you say A? Izu? Huh? No idea. Okay. Do you agree with him? Izu said A. Yachewe.
Yes.
You agree with me, with him? So why did you agree with him?
Sir, because when the solid is in a grounded powder, you don't know if there is any other substance that is added that is in that solid.
Is that what you wrote as your answer?
That's why I can answer.
You not write any answer. That means you know the assignment now. Chinaya,
So I first
see, sit up.
I see.
See, what did he say? Solid begins to melt at 573 Kelvin, but it's not completely melted until 648 Kelvin. So why did you choose C?
Because so something in the mixture. So because so I don't know.
You don't know. You just chose C without a reason. Wow. The answer is not A. Let's look at the question again. In an experiment, which of the following observations would suggest that a solid sample is a mixture? A says solid can be grounded to a fine powder. If it grounds, even a compound can be grounded to a fine powder. True of us. True of us. Don't we have powdered sulfur? True of us. So that is not the answer. A mixture can be grounded to a powder. So far you apply the force that can grind it well. True of us. Even this chair can be grounded to a powder. True of us. If we have a machine that can apply enough pressure that can grind it, it will turn to powder. True of us. So that is not the answer. B. The density of a solid is 2.25 grams per dm cube. This one is just there to confuse you. C. Solid begins to melt at 573 Kelvin, but it's not completely melted until 648 Kelvin. Remember what I told you in our last class? If you go through our last lecture, you will remember that I said that a mixture contains different substances, can be element, can be compound, that have their own individual what? Melting point, true or false? Or boiling point if they are liquid, true or false? Now, because of this composition of different substances with different metals, so for the entire mixture to completely melt, it will pass through these different stages or different melting point of all these constituents. That's why it doesn't have a particular temperature as its melting point. It's a range from this to what? It will start at a particular temperature and everything will finish melting at a particular what? Temperature. That's why the answer is C. They say the solid begins to melt at 573 Kelvin, but it's not completely melted until where? 600 and what? 48 Kelvin. So it's a range. So the melting range of this compound now is what? Of this mixture now is what? 573 Kelvin to what? 648. So it's not fixed because it's a mixture. Is it clear? Good. Now D said the solid melts at 300 Kelvin. If a solid melts at 300 Kelvin, that means it's a pure solid now. True or false? It's a pure solid. That means it's either an element or a what? A compound. So D is not the answer. The answer is what? C. Number 4. A process that involves a physical change is A. Burning of butane gas. B. Exposing sodium metal to air. C. Subliming sulfur in hot air. D. Dissolving sodium hydroxide in water. Chidayoya, what's the answer? C is what?
Subliming sulfur in hot air.
Why do you say C?
Because, like, in my physical change, so physical change will like after undergoing the change, like a new substance will not form, or yeah, reversible. So burning of butane gas is not reversible. Exposing sodium metal to air, reversible air turn to zero. What is me and then that dissolving of sodium hydroxide in water. In may react with my oxygen, my water, my oil form. So then that subliming of sulfur in hot air. That after like a sublime in hot air on cooling or to the normal yield. Yeah.
What do you think? D. D is what? Dissolving sodium hydroxide in water. Why did you choose D?
After dissolving sodium hydroxide in water, when the solution is heated, sodium hydroxide can be recovered.
Are you sure?
Yes.
You don't do assignment. This assignment. Oh yeah, answer.
C.
C. What do you say? C.
In the physical change, if after this non substance will be formed.
Izu, you use the idea of what happened in sodium chloride of here, right? It doesn't hold in every substance, okay? Now, when sodium hydroxide is dissolved in water, ions will form, okay? Okay, ions will form. And this formation of ion is a chemical what? process. It's a chemical what? Process. So, but if you burn butane gas to form carbon dioxide and oxygen, that one is gone. The same thing, if we expose sodium metal to air, sodium is very reactive. Sodium oxide and what have you before. If you sublime sulfur, but this sulfur thing with hot air, you should really careful because that's how we do it. Sulfur oxide will form. But that's how they do it, how it will carry it out. It will still be sulfur. The sulfur will leave solid form. Bypass liquid form and form what? Gas, sulfuric gas. Okay? Now that gas will form can also do what? Go back to the what? Solid when cooled down, when cooled. Okay? So among three of these four options, C, subliming sulfur in hot air is a physical what? Change. Number 5. By means of filtration, one component can be obtained, pure, from an aqueous mixture of sodium chloride. By means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride and A, potassium nitrate, B, sand, C, lead nitrate, D, sugar. Izu? Huh? Sand. Why do you say sand, Izu?
One sodium chloride mixed with sand.
Huh?
One sodium chloride mixed with sand.
Okay.
If you want to recover the sodium chloride, we add the mixture water.
Okay.
And when the sodium chloride dissolves in water,
Okay.
we then filter the mixture
Okay.
and the sand will come out.
Good. Can you clap for him, please? I like this explanation. Can you clap well? Clap well. Clap well. Clap well. Don't have to clap. He described this like a chemist. And that is how a chemist or chemist student should be describing things. Huh? This is how a chemist or chemist student should be describing things. I like that explanation. Makes sense. Which one did you choose?
Sand.
Why do you say sand?
Because I mean, your face means that now here, no, I sand like this potassium nitrate, all the soluble. So when we say with this sodium chloride in aqueous solution, when you filter it, like if you want to undergo that, even if you filter this potassium nitrate will also pass in that filter paper, but this sand, like all the insoluble, so you may command this thing. You cannot filter it.
Other simple. Other simple.
This lead nitrate, by means of filtration.
Why?
So because all the soluble.
Are you sure?
Then sugar because soluble. Sugar when you take the man have to evaporation among come shama no make able. I draw key with it because it's sugar and so if it up the matter you fit it now.
Sit up. What's the answer? You didn't do it. Now, you know why I said you should clap for him. He started from the scratch, even though the question says by means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride. That means you already have the solution, the mixture as a solution and a filter. But he said it from the beginning that you if you have a mixture of sand and sodium chloride, and you want to separate them, you simply do what? Pour water in the what? Mixture, right? Then the sodium will dissolve, right? Then you filter it. Sodium will come out as a filtrate, right? What will be left as residue is what? Sand. You have separated it. True or false? So the answer is what? Sand. If you want to go further to recover the sodium chloride, what do? You do what? Who knows? You do what? Huh? You heat it, right? To evaporate the water, right? The water will be evaporated. So what will remain is what? Sodium chloride. Okay. Any question? Any question? Any question? All right. In the absence of any questions, we call it a day. All right. See you next time.